Alright, so before we talked about resolving vectors, which had to do with different components, and that's what we're going to do here. We're going to take the projectiles we launched earlier, but we're going to use them at an angle. And in order to find those out, we have to find out the x and y's of those velocities and everything else to get our answer, whether it be the height, or the distance ago, the time. We want to find out how long it was itself, or how maybe just whatever the max was, or maybe we want to find out how high it was at 5 seconds. Alright, so let's say we have a golfer, and he hits a distance of 301.5 meters. I have no idea if that's great enough. So obviously the maximum height's going to be here, and that's what we're going to find out today. We want to know how high he hit. So we have a curve here, but if we have this, which we do, we can turn this into a triangle. Right here. So we know the x here. We know that at this point it's going to, before it turns back down to the earth, it's going to have a velocity of 0. And this is halfway between this and this. So that's that. We talked about it being parabolic trajectory before. We talked about projectiles launched. What difference is an angle? So your angle goes here. So in order to figure this out, we have the x here, and all we have to do is divide this in half. So this is x over 2. And we want to know this y. So since we don't have the hypotenuse, we have to use tangent of the angle. Told you before, in pleasure cases you would. So tangent of the angle is equal to opposite over adjacent. We have trying to get the opposite, and we have the adjacent. So we need, yes. So we need to rearrange this. Tangent of theta times the adjacent. We're going to put on this end because we're going to do that anyway later. Equals the opposite. And let's put that more in terms that we'll better understand. So x divided by 2 times the tangent of the angle is equal to the y. Now so our equation here then turns into 301.5 meters over 2 times the tangent of 25 degrees. And you understand that divided by 2 is because we have the whole x here, but we only need half it because we just want to find this triangle. So when we get that, the answer becomes 70.3 meters. So the highest point in his parabolic trajectory that he reaches is here, right here. See, that trick wasn't so hard after all. You're good.